Some scientists have proposed a radical idea, using nuclear weapons to terraform Mars. Terraforming means transforming a planet to make it more like Earth and suitable for human life. The idea is based on the principle that nuclear explosions could release greenhouse gases trapped within the Martian soil and ice caps. These gases, like carbon dioxide, could potentially thicken the atmosphere and trap heat, leading to a warmer, more Earth-like climate. This concept, while seemingly drawn from science fiction, has sparked serious debate about the feasibility and ethical implications of using such powerful and destructive technology for planetary engineering. The allure of nuclear terraforming lies in its potential for rapid and dramatic change. Proponents argue that detonating nuclear devices at strategic locations could trigger a runaway greenhouse effect, melting polar ice caps and releasing trapped water vapor. This water vapor, along with the released carbon dioxide, could create a denser atmosphere capable of supporting liquid water on the surface and shielding inhabitants from harmful radiation. In essence, the goal is to kickstart a chain reaction that would transform Mars from a cold, arid desert into a potentially habitable world. However, the potential benefits of nuclear terraforming are overshadowed by significant challenges and risks. Detonating nuclear weapons on Mars could have unintended and potentially catastrophic consequences. One of the biggest hurdles is the thin Martian atmosphere. Even if nuclear explosions release greenhouse gases, Mars' weak gravity might not be strong enough to hold on to them. The gases could simply dissipate into space, rendering the terraforming effort futile. Another major concern is the issue of radioactive fallout. Nuclear explosions would release radioactive material into the Martian environment, potentially contaminating the planet's surface and atmosphere for centuries. This radioactive fallout could pose significant risks to any future human colonists and could even hinder the development of life on Mars. The long-term effects of nuclear explosions on the Martian geology and climate are also uncertain. Detonating nuclear devices could trigger seismic events, disrupt the planet's magnetic field, or even have unforeseen consequences that could make Mars less habitable. Given the immense challenges and risks associated with nuclear terraforming, scientists are exploring alternative approaches to make Mars habitable. These include gradually releasing greenhouse gases from Martian soil and polar ice caps through more controlled methods, such as orbital mirrors or specialized factories, placing giant mirrors in orbit to reflect sunlight onto the Martian surface, increasing temperatures and potentially melting ice, introducing genetically engineered microorganisms that could consume carbon dioxide and release oxygen into the atmosphere, simulating a process similar to Earth's early atmosphere formation. While these alternative approaches may require more time and resources, they offer potentially safer and more sustainable ways to transform Mars into a habitable world for future generations. Nuking Mars, while a tempting concept in science fiction, remains a highly controversial and impractical solution in reality.